All right, hello pre-calculus students. You thought me being gone would mean that you wouldn't have to learn anything today. Well, that's not it. So today we're going to do some modeling with equations, which means your homework is all, wait for it, word problems. Before you flip out, I know that doing this on a day that I'm not there is not the best, but all these word problems that you're assigned are kind of baby word problems. You're practicing writing down equations from the words, and we'll deal with more complicated ones next time. All right, here's our first example. Suppose you have 3 test scores, and your first 2 test scores are 78 and 82. And I want to express that average in terms of S, which is a third test score. So we know our first 2 test scores, not our third and 1 average. Well, the way you find the average of 3 test scores is you add them all up and divide by how many. So our average will be 78 plus 82 plus S, that's the unknown one, divided by 3. So that's an expression for the average of 3 test scores. Oops, I did the wrong thing. That shouldn't say 83. That should say 82. I was ahead of myself there. So that's the average of your 3 test scores with one of them unknown. Now you want to know what this last test score has to be to obtain an average of 83. So you set this equation equal to 83, and then you solve it. And it's not that hard. Let's add together the 78 and the 82. And that's 160 plus S divided by 3 equals 83. Next, let's multiply both sides by 3. So multiply by 3, multiply by 3. These 3's cancel. We're left with 160 plus S equals 83 times 3 is 249. And now lastly, we take away 160 and find that the score on the final exam has to be an 89. So an 89 is needed on exam number 3 to have an 83 average. And you can use this in your classes if you're ever trying to figure out what grade do I have to get on the final to have a certain score in the class. We can talk about that later in the semester for what happens if you have weighted grades. Just remind me when we get close to the end. Okay, another one. A rental company charges $65 a day and 20 cents per mile for renting a truck. Suppose you rented the truck for 3 days and your bill came out to $275. How many miles did you drive? So we need an equation for the cost of driving that truck, depending on how many miles we have driven. And it would also matter how many days, but we were told that, it was 3 days. So the cost for driving that truck is equal to 65 times 3, since that is the upfront cost you pay per day, plus 0.2 times however many miles you go. So call it M, call it X, who cares? And we know that the cost was $275. So that $275 can go in for the cost. So $275 equals, 65 times 3 is 195 plus 0.2 M. Subtract the 195 from both sides of the equation, and you get 80 equals 0.2 M. And then divide by 0.2 on both sides, and you get that M equals 400 miles. So 400 miles were driven over those 3 days. So not so hard. Your job and your homework is to just attempt the problems. Just try. That's all I ask. All right, here's another example. Suppose you earn $7.50 an hour on a job, which is, by the way, like kind of a terrible hourly wage. But if you work more than 35 hours, you're paid overtime at a rate of 1.5 times your normal hourly pay, which makes it only slightly better. 1 week, your gross pay totals to $352.50. How many overtime hours did you work? So we need an equation that tells us sort of like what our pay is. So this person's pay, we'll call that P, assuming that if they worked overtime, that means they had to work the full 35 hours in the week. So their pay for those 35 hours is 35 hours times $7.50 per hour, giving you how much they earned for the base amount of time. Plus, you don't know how many overtime hours, so that's your X. And you need to figure out how much they're paid per overtime hour. Well, that's whatever $7.50 times 1.5 is, because the rate is 1.5 times as much, multiplied by however many hours, so I'll just call that X. So that's P equals 262.5 plus 1125X. And we know that the pay was $352.50, so plug that in and start solving for X. So take away the 262.5. So 352.50 minus 262.5 comes out to be 90. So 90 equals 11.25x. Then divide by 11.25. And I found that x equals 8. And that's 8 hours of overtime. So those three situations I would consider sort of more real-life-ish algebraic equations. The next three equations and the other kinds you'll have on your homework are geometric equations. So you have to know how to find areas of rectangles. I know it's a really high standard, but I think you guys can do it. So we have a rectangular garden, and it's 25 feet wide, and we know that the area is 1,125 square feet. What is the length? So you have let's see if this works. Yeah, there we go. Rectangular garden. And one side is 25, one side you don't know, call it X. You know that the area, which is length times width, is equal to 1,125. You know one side is 25, you know one side is X. Wow. So that's a really hard equation, guys. Can you do 1125 divided by 25? And I get that X equals 45. Give it units, it's feet. So 45 feet long. And so totally baby problem. All right, let's do another one like that. So we have a half-acre building lot that's 5 times as long as it is wide. So long and skinny. What are its dimensions? Note that 1 acre is 43,560 feet. That was my random fact for the day. Okay, so we know that the area of this thing is half an acre. So the area is half of 43,560, which is 21,780. Okay. Now we're also told that one side is 5 times longer as the other. So if I call the short side X, the other side is 5X. And from there, it's pretty easy. You know that area is length times width. So the total area is 21,780, and it's equal to X times 5X. So that's 21,780 equals 5X squared. Divide both sides by 5, and you get 4,356 equals X squared. Now square root both sides, and technically this works out nicely. It's kind of cool. You get X equals plus or minus 66, like technically. But this X is a length, so it doesn't make any sense for it to be negative. Also, be careful that you answer what the question asks for. It asks for the dimensions of this lot. So the dimensions are 66, that's the short side, by whatever 66 times 5 is, which is 330. So 66 by 330 are the dimensions. And remember that your homework is graded in this sort of binary right-wrong fashion, so if you don't actually give both dimensions, you're technically marked wrong, even though you're basically almost right. So watch out for that. Okay, one last one. A rectangular garden is 10 feet longer than it is wide. Its area is 875 feet squared. What are its dimensions? Okay, so we have some kind of, once again, rectangle. And so one side is x, and one side is 10 more than x. So in this case, instead of being x times 10, it's x plus 10. And we're told the area is equal to 875 square feet. And so same idea. We know that the area is length times width. So 875 is equal to x times x plus 10. And solving this equation will be a little bit more difficult, but not ridiculous. 875 will equal x squared plus 10x. Take away the 875, and I get 0 equals x squared plus 10x minus 875. And if you look at this and you cannot easily determine whether or not it factors, I would suggest using the quadratic formula. That would be my suggestion. I just happened to get lucky and observe that 25 went into 875, and 875 is equal to 25 times 35. And so if I make the 25 negative and the 35 positive, those two numbers multiply to negative 875, and they add up to 10. So this factors as x minus 25, x plus 35. And there's basically no way I'd expect you to do that on a test without a calculator, so just don't worry about that. And so we get that x is equal to 25, or negative 35. And negative 35 makes no sense because x is a dimension. Okay, so our one side and our dimension is 25 feet. The other side is 10 more, or 35 feet. Now, probably some of you are wondering or asking, like, well, geez, we got 25 by 35, and that second answer, that was negative 35. And so is it the case that it's always opposite that? And the answer is, I'm not sure. I'd have to think more about whether or not that works, and I suspect that it's just a coincidence, not an actual pattern, but I could be wrong. Okay, so that's it for the problems. You need to try a bunch of problems that are like that, plus take your quiz on 1-6. So here's one last a note about the homework. I know some of these problems are really intuitive for students, and you don't always have to write your work down. But I want you to practice writing the equations, because the next time we do this and later on in the course, we're going to have more complicated equations and you need the practice. So even though it takes you 5 extra minutes, please take those 5 minutes and actually practice writing equations down and then see if they match with the solution you get from your intuition, if you can do all of these in your head or without showing your work. All right, have a great day.